Today we're going to be talking about partial fraction decomposition. It's a process of integration that involves making a difficult to integrate function easier to integrate. Partial fraction integration comes in the form of f of x over g of x, or one function over another. We can only use partial fraction decomposition when f of x is a lower degree polynomial and g of x is a higher degree polynomial. So if we take the example x plus 1 over x squared plus 1, x squared has a degree of 2 and x has a degree of 1, so this works. If we take an example of x to the third over 4x, x has a degree of 1 and x to the third has a degree of 3, so it does not work because f of x, or the top function, has a higher degree polynomial. Example 1. If we take the function x plus 2 all over x squared minus 1, and we're going to attempt to use partial fraction decomposition on it, the first step is to determine if it works by testing the degree of the polynomial. The top one gets a degree of 1 because it's x to the first, and the bottom gets a degree of 2 because it's x squared. So this works. The next step is to break down and decompose the bottom half of the function into x minus 1 times x plus 1. And we're going to set that equal to a over x minus 1 plus b over x plus 1. Both a and b are variables that we have not determined the value of yet. To simplify, we will multiply both sides by the denominator of the left side. So x minus 1 times x plus 1. If we simplify the fraction, we get that the equation is x plus 2 equals a times x plus 1 plus b times x minus 1. We're going to take this equation and go to the next page with it. The first step is to take the bottom function from our original total function and to find the zeros of it. G of x equals x minus 1 times x plus 1. You set it equal to 0 and use algebra to solve. You get negative 1 and positive 1 as the zeros. Now we're going to plug these numbers into the above red equation. First we'll start with negative 1. When we solve this out, we get 1 equals a times 0 plus b times negative 2. We continue to simplify. It's just algebra. You get negative 1/2 equals b. Now we're going to use the other factor, which is just 1. If you continue to simplify, you get 3 equals 2a plus 0b. 3 equals 2a, so a equals 3 over 2. And we're just going to write b here so that we can remember it. b equals negative 1/2. Now we go back to the function that said x plus 2 all over x squared minus 1 equals a over x minus 1 plus b over x plus 1. And we're going to fill in a as 3/2 and b as negative 1/2. And this is actually the partial fraction decomposition that equals the other function. Now what happens when we take x plus 2 over x to the third minus 2x squared minus x plus 2? It has a degree of 3, where before it had a degree of 2, so we used 2 variables. But now, because it's a third degree polynomial on the bottom, and we have to break it into 3 parts, we're going to have to use a new variable. A will be over 1, b will be over another, and we're introducing a new variable, c, that'll be over the third part. And you solve it the same way by multiplying by the denominator on both sides. The summary of partial fractions is that it comes in the general form of f of x over g of x, one function over another. And we break it up into a over one factor plus b over another factor, and so on, depending on how many factors we have. But we can only use partial fractions when the denominator has a higher degree polynomial than the numerator. Alright guys, thanks for watching. If you want to learn more about partial fraction decomposition, click the link below to go back to our site.